I'm here, Jacob, presenting a paper titled A Survey on Data-Driven and Knowledge-Aware Explainable AI. The authors are on the slide as well. The abstract shows that the paper proposes a survey reviewing and taxonomizing existing efforts from the viewpoint of DKE, summarizing their contribution, technical essence, and comparative characteristics. Specifically, they categorize methods into data-driven methods where explanation comes from the task-related data, and knowledge-aware methods where extraneous knowledge is incorporated. For the abstract review, overall the paper provides a deep understanding of the concept of XAI along the three lines based on the phases of the life cycle of XAI to review the related works along the lines of methodology, evaluation, and application. This gave a good summary of the contents of the entire paper. When we review the introduction defined key terms to be used in the paper. It introduces computer vision, deep learning, DNNs, the black box model. It also talked about the life cycle, the need and the importance of XAI, explainable artificial intelligence, to users of technology at a layman level and expert level. A related work review. This section gave a good glance at the existing surveys, comparing them from the following perspectives: domain, methodology, evaluation, and application. It also talked about the application of explainable AI still being at a premature stage. Data-driven explainable AI review. It defines the data-driven explanation of AI as the methods that generate explanations purely from data without external information such as prior knowledge. The section also talks about methods that can be further categorized into global or local ones according to the scope of explainability, namely whether they explain global behavior for all points or a subset of predictions. Furthermore, global methods aim to provide understanding of the logic of a model and the complete reasoning for all the predictions based on a holistic view of its features, learn components and structures, while local methods attempt to justify the model behavior for a single instance or a set of instances. Local behavior of complex models can be correlated to fewer features through simple relation. On the section of prototypes and criticisms review, prototype can be defined as a representation of a data instance from the original dataset, and while a criticism is a data instance that is not well represented by the set of prototypes. The section of knowledge-aware explainable AI. With external domain knowledge, we generate explanations that not only indicate the feature importance, but also describe the reason why certain features are more important than others. These are further broken down into two categories: general knowledge methods. These take unstructured data as their knowledge source, and knowledge-based methods which construct explanations with the foundation of structured knowledge data. One of the components of structured knowledge data is a knowledge corpus, and it's defined as a way to address and it contains a domain of knowledge or concepts that are imported into the AI system, which helps with explainability in a user-friendly manner. Still on knowledge-based methods, we focus on the explanation of methods with structured and unsystematic data, abbreviated as KB, and it is often modeled as a knowledge graph KG. KG can be applied in two forms: internal and an internal route, and an example of that are recommender systems or external route. These ones use abductive reasoning, and an application would be use of abductive reasoning to treat diabetic patients. In the section of metrics, the researchers noted that many questions are still being asked about the validity of results centered around the black box model, and there are very many evaluation metrics that I've captured in four aspects around the questions entail some around four aspects, which is goodness, satisfaction, comprehension, and performance measuring. The evaluation methods are further grouped into two categories: computer metrics, which are understood by experts, and cognitive metrics, which are understood by non-experts. On the section of scenarios and applications, the researchers provided two carefully thought out scenarios, such as self driving cars and financial AI, which give a good example of how explainability of AI can be brought to real life. These two captured the concept well and were good examples. And the lessons to adopt in my group project, I will ensure that there is an element of explainability in my model in detecting patients who are most likely to fail on their treatment. And with that, I thank you.